This is Bob Capetta from the College of the Florida Keys, and this lesson is on graphing equations. We're going to take a look at the equation 3x plus 5y equals 10, and we're interested in which points make that statement true. So I'm going to try some and see what we think. The first question I'm going to ask is 0, 2 on this line. So if I plug 0 in for x, and 2 in for y, do I get a point on the line? Well, I'm plugging in 0 for x, 3 times 0, plugging 2 for y, plus 5 times 2. Is that equal to 10? 3 times 0 is 0, plus 5 times 2 is 10. 0 plus 10 equals 10, so indeed that's true. So the point 0, 2 is on that line. How about the point 3, 1? Is that on the line? Plugging in a 3 for x, 3 times 3. Plugging in a 1 for y, 5 times 1. What does that give us? 3 times 3 is 9. 5 times 1 is 5. Does 9 plus 5 equal 10? No, it does not. So that point is not on the line. 3, 1 is not on the line. How about 5, -1? 3 times 5 is 15. 5 times -1 is -5. 15 plus -5 is 10. So indeed, 5, -1 is on the line. So we found 2 points on the line. 5, -1 is one of the points on the line. And the other one was 0, 2. So 0, 2 and 5, -1 are on the line. So here's 0, 2. 0 in the x direction, 2 in the y direction. 5, -1, 5 over 1 down, to go ahead and give us 2 points on the line. So if we're going to go ahead and construct that line, what will that look like? It will look like this. And notice the computer gave us a third point that crosses the x-intercept. All you need are 2 points on the line to get a line. Other types of shapes will need more than 2 points, but that's all you need for a line is 2 points. Okay? Next up, I'm going to look at 5x minus 2y equals 4. So I would like to find 2 points on the line so that I can graph it. And I'd rather not have points with fractions. So is there an obvious one to choose for 5x minus 2y equals 4? Well, sometimes it's helpful to let the x or the y be 0. If I let y be 0, I would get 5x equals 4. That's going to give me fractions. But if I let x be 0, 0 minus 2y equals 4. That would be requiring me to check 0, -2. So let me ask the question, is 0, -2 on this line? 5 times 0 minus 2 times -2. Minus 2 times -2 is plus 4, so I get 4 equals 4. Yes, it is. So 0, -2 is a point on the line. Now, can I find another one? Is there a way for me to think about a point that might be on that line? Well, that's not easy to do. If I let x be 2, I get 5 times 2 is 10. Maybe that's something I could try. So I'm going to ask myself, is 2, 3 on this line? 5 times 2 is 10. 2 times 3 is 6. 10 minus 6 is 4. So indeed, that point 2, 3 is on the line. But that's difficult to do, just to arbitrarily come up with a point that is going to be on the line. But we have found 2. 2, 3 is on the line. 0, -2 is on the line. So there you can see them. Here's 0, -2. And here's 2, 3. We have 2 points on the line, so that is enough for us to graph it. And it looks something like that. But there's an infinite number of points on the line. But notice, you're not seeing many crossing at intersections of the vertical and horizontal line. So we're not going to have an easy time coming up with points on this line. All right. Now we're going to graph nonlinear equations, because not all equations are lines. If I have y equals 5 minus x squared, I'm going to plug in various values for x and see what I get for y. So it's often a good thing to start at 0. So if x is 0, y is 5 minus x squared, 5 minus 0 squared. 0 squared is 0, so we get y equals 5. So 1 point on this graph is x is 0, y is 5. Let's go to 1. X is 1, y is 5 minus x squared, 5 minus 1 squared. 1 squared is 1, 5 minus 1, y is 4. Let's go to x is 2. Y is 5 minus x squared. Y is 5 minus 2 squared. Y is 5 minus 4. Y is 1. So 2, 1 is a point on this graph. We go to 3. 5 minus 3 squared. 5 minus 9. 5 plus negative 9, negative 4. So now I have 4 points, 0, 5, 1, 4, 2, 1, and 3, negative 4. I don't have any negative x values here, so it might be helpful for me to plug in some values of x that are negative. So let's do that. If x is negative 1, 5 minus, in parentheses, negative 1 squared. In parentheses, negative 1 times negative 1 is positive 1. Hence, 5 minus positive 1 to give me a y of 4. If x is negative 2, 5 minus x squared. 5 minus negative 2, in parentheses, squared. 5 minus 4, y is 1. We'll plug in negative 3. 5 minus x squared. 5 minus negative 3 squared. 5 minus 9. And y is negative 4. So I have 3 more points. X is negative 1, y is 4. X is negative 2, y is 1. X is negative 3, y is negative 4. 3 more points I can add to that graph. So here's all the points that I have. I have 7 different points on that graph. So let's go ahead and graph those. 0, 5, 0 on x, 5 on y is here. 1 on x, 4 on y, first quadrant point. 2 on x, 1 on y, first quadrant point. 3 on x, negative 4 on y, fourth quadrant. Remember quadrant 1, 2, 3, 4. 3 on x, negative 4 on y, fourth quadrant point. Negative 1 on x, 4 on y, second quadrant. Negative 2 on x, 1 on y, second quadrant. And negative 3, negative 4, third quadrant. So when we connect those, we get a parabola that looks like this. So second order equations, quadratic equations, usually look like parabolas. This is an opening down parabola because the x squared term is negative. It was 5 minus x squared. Let's look at our next example of a non-linear equation. So this is not going to be a straight line, some other sort of graph. We have y equals 1 over x. We're going to pick various values for x. Cannot pick 0. Y equals 1 over 0 is not defined. 0 is not in the domain of this function. But if I pick x equals 1, y is 1 divided by 1, or 1. If I picked x equals 2, y is 1 divided by 2, or a half. If I pick x is 3, y is 1 divided by 3, which is a third. Okay, so those are all positive values of x. Let's choose some negative values of x next. If I have x is negative 1, and y is 1 divided by negative 1, or negative 1. X is negative 2, y is 1 divided by negative 2, or negative 1/2. X is negative 3, y is 1 divided by negative 3, which is negative 1/3. To finish up the list of points I'm going to use for this problem, I'm going to choose some fractions. If x is a half, 1 divided by a half, invert and multiply. 1 times 2, we get 2. X is negative 1/2. 1 divided by negative 1/2 is negative 2. So I have 8 points so far. 1, 1, 2 1/2, 3 1/3, negative 1, negative 1, negative 2, negative 1/2, negative 3, negative 1/3, 1/2, 2, negative 1/2, negative 2. I have all of those points. I'm going to graph them, and you'll see what it looks like. So we have asymptotic behavior, asymptote. It's going to be curving up towards the y-axis, curving down towards the x-axis. Here, notice a quarter, a fifth, a sixth, a seventh going this way. Same way, curving towards the x-axis here, curving towards the y-axis here. And the graph will look like that. So that's what y equals 1 over x looks like. Again, 0 is not in the domain of the function. There is no y value when x equals 0. Okay, we've got one more equation to look at here in this lesson. Y is the absolute value of x minus 2. Let's make sure we know what absolute value means. Absolute value is distance from 0. Absolute value of 7 is 7. Absolute value of 9 is 9. Absolute value of 27 is 27. But the absolute value of negative 3 is positive 3. Absolute value of negative 5 is positive 5. Absolute value of negative 18 is positive 18. So the absolute value of something is the positive value. Ignore the sign, make it positive. That's our idea. So we're going to choose some values here. Let me first choose x equals 0. plugging in the 0 for x, absolute 0 minus 2. So y is absolute value of negative 2, which gives me positive 2. If x is 1, plugging in the 1 for x, I get absolute 1 minus 2. So y is absolute value of negative 1, which is positive 1. Plugging in 2, y is absolute 2 minus 2, y is absolute value of 0, which is just 0. Plugging in 3, absolute value of 3 minus 2, absolute value of 1 is positive 1. And plugging in 4, y is absolute value of 4 minus 2, y is absolute 2, y is 2. So I have 5 points, and frankly, that's probably all that I need. So I have 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. If I chose negative 1 minus 2 would be negative 3. Absolute value would be positive 3. So in my mind, I can think negative 1, 3 is also there. So notice where negative 1, 3 would be. Here's negative 1, here's 3 up there. So if I connect all these points, it's not going to have a nice curve point at the bottom. It's going to have a sharp corner. So this absolute value equation will look like this. And what we've looked at in this lesson is graphing lines as well as graphing nonlinear equations. For lines, you just need 2 points. For nonlinear equations, you need a whole lot more, and it's just a matter of point plotting, plugging in numbers to get your answers. And that will conclude this lesson.